Welcome to Brain Vision.
Given f of x, which is equal to sine of 10 pi over x, which passes through the point P, which is coordinates 1, 0, we need to find the following. First, the slope of the secant lines through the x values, and then we need to explain why these slopes of the secant lines in part A are not close to the slope of the tangent line at P, and lastly, we need to choose appropriate secant lines to estimate the slope at P. Now for the first one, to find the slope of the secant line, we use the formula for the slope of the line, which is just the change in y over the change in x, which in this case will be f of x minus f of 1 over, that'll be x minus 1. Now since f of 1 is 0, then we have f of x all over x minus 1 as the slope of the secant line. So we will use this formula to find the slope of the secant lines through these given x values. Now for us to see a pattern, we will do a table, and in this table we will write our x values in order. So for x, which is 0.5, we have sine of 10 pi over 0.5, that's divided by 0.5 minus 1, we have a value equal to 0. And if it's 0.6, we have sine of 10 pi over 0.6 divided by 0.6 minus 1, we get negative 2.1651. At x equals 0.7, we have sine of 10 pi over 0.7 over 0.7 minus 1, that gives us negative 2.6061. At x, which is 0.8, we have sine of 0.8, rather 10 pi over 0.8 over 0.8 minus 1. This gives us negative 5, and if it's 0.9, we have sine of 10 pi over 0.9 over 0.9 minus 1. This gives us 3.42020. If x is 1.1, we have sine of 10 pi over 1.1 divided by 1.1 minus 1. We have negative 2.8173. And if x is 1.2, we have sine of 10 pi over 1.2 all over 1.2 minus 1. That gives us 4.3301. If x is 1.3, we have sine of 10 pi over 1.3 over 1.3 minus 1. This gives us negative 2.7433. And if it's 1.4, we have sine of 10 pi over 1.4 divided by 1.4 minus 1. We have negative 1.0847. And if it's 1.5, we have sine of 10 pi over 1.5 over 1.5 minus 1. This is just 1.7321. And lastly, if it's 2, we have sine of 10 pi over 2 minus 1. We have slope equal to 0. Note that as we move closer to x equals 1, the value of the slope is not really approaching a value close to each other. So we are not really seeing a pattern here. So to estimate the slope of the tangent line at P, let's look at the graph and from there choose the correct points to form the secant lines. Below is the graph of the function. In here we see that the function is changing rapidly from increasing to decreasing. And so this is the reason why we're not seeing a pattern for the slope of the tangent line. And so for part C, to choose the correct points, we will use the x values just right here. That will be x values in between 0.95 and 1.05. Let's say x is 0.9, 0.999, and then for x values right of 1, let's say we have 1.0001, and then 1.001. And then from here, we find the slopes of the secant lines. We do the same process as what they did in part A. We make a table and then find the slope there. Below is the table of values. Now, if x is 0.99, we have sine of 10 pi over 0.99 over 0.99 minus 1, we get negative 31.2033. And if it's 0.999, we have sine of 10 pi over 0.999 over 0.999 minus 1. This gives us negative 31.4422. Now if x is 1.0001, we have sine of 10 pi over 1.0001 over 1.001 minus 1. That gives us negative 31.4127. At x equals 1.001, we have sine of 10 pi over 1.001 over 1.001 minus 1, we get negative 31.3794. Therefore, the slope of the tangent line at P is approximately negative 31.4. This is because as we move closer to 1, the value of the slope is approaching negative 31.4.